All right, class, welcome back. Another section or another objective from 7.7, our complex number system, is to divide complex numbers. These will look something like this, 7 divided by 3i. Essentially, this is just like when we had, 7 over 3 square root of 2. And our goal here was to get the radical out of the denominator. So we would multiply both the top and the bottom by the square root of 2 and get 7 square roots of 2 over 3 times the square root of 2 times the square root of 2, which was 4, which would end up like so. We're going to do the same thing here, except for here we want to get the conjugate out of the denominator. Sorry, we want to get the I, or the imaginary unit, out of the denominator. So it'll just say to divide. Okay, the instructions will say divide and write in the form a plus bi. Okay, so I want to get this I out of the denominator. So I am going to multiply both the top and the bottom by I. And that will give me 7i over 3i squared. Remember, I squared is worth -1. So this is really 3 times -1. So my end result here would be 7i over -3. Now again, it says to write it in this format. It's important to note that this is correct, that negative can be here, the negative could be here. Doesn't really matter where that negative is. This is the bi part. So technically this would be like 0 minus 7i over 3 if you're going to write it in this a plus bi, but this answer here would also be acceptable. So that's if you have a single term or a single I in the denominator. Let's do one more. Let's say that you had a 5 over a 6i. Well, again, all you're wanting to do is just get rid of this I in the denominator. So you're going to multiply both the top and the bottom by I. That's going to give you a 5i over 6i squared. I squared has this value of -1. So this is going to be 5i over -1, which again can be written like this. Where this negative is doesn't really matter, or you can have this 0 up front. This should be a 6 here. Sorry, I didn't finish writing the 6. 5i over a -6. Again, the negative's right here. Okay, so either way you want to write this is fine. So this is with a single term in the denominator. But what if I had 2 terms in the denominator? Again, the directions would stay the same. It would just say divide and write in this format. So what would that problem look like? Well, it might look something like 3 plus I over 2 minus a 3i. Now, I left this conjugate information here because, again, we just want to get this imaginary number out of the denominator. And the way that we're going to do that is by multiplying by its conjugate. So it's going to be the same 2 terms, but with opposite signs. When we FOIL this, on the bottom, we're going to get 2 times 2, which is 4. We get this positive 6i and a negative 6i. And then a negative times a positive will give you a -9, but I have I squared. So again, remember when we use a conjugate, the whole point is that these middle terms sum to 0. So those are gone, and this negative, or this I squared, is going to be multiplied, or is going to be replaced with -1. So we've got 4, -9 times -1 is +9, so on the bottom we have 13. So this is what we have in the denominator here. It's just this whole number 13. But now I need to simplify the top and combine these, so I'm going to get 3 times 2, which is 6, 3 times 3i, which is a positive 9i. When I do the inners, I'm going to get plus a 2i. And when I do the last, I'm going to get plus a 3i squared. These are like terms, so I can combine them, and I need to replace this I squared with the value -1. So I'll have 6 plus 11I minus 3, which is going to give me 3 plus 11I. This is what I have on top, and 13 is what I have on the bottom. So again, the directions will say divide and write in the A plus BI form. Also, I want you to note that you might not see it like this. They might have it written because they want this separated out like this. 3 over 13 plus 11I over 13. So they're separated out. This 13 belongs to both, which you already knew, and we've done simplification of that kind of thing. So I want to do one more problem with a 2-term denominator. And again, we're not going to go super deep into this, and it's all going to be stuff that you've seen before. We're just working with this imaginary number, imaginary unit of I, which we're going to treat like any other variable when we are multiplying, but it does have certain values that we can substitute to simplify further. Okay, so next problem with a conjugate. Let's try a 4 minus I. I don't know, let's say over 2 plus a 5I. No, that's too similar to the last one. Let's do a 2 plus 7 plus 2I. There we go. So again, I'm just going to think, oh, this says divide, but I don't even know what that means. Well, what it means is I want to get rid of this. So when you hear the word divide, think, and it's a complex number, you have i's, think conjugate. I want to multiply by the conjugate. So conjugate here is going to be 7 minus a 2i, same 2 terms with opposite signs. Whatever you do to the bottom, you have to do to the top. So when I FOIL this, I'm going to get 7 times 7 is 49, a minus 14i, and a plus 14i, and a minus 4. 2 times 2 is 4. I times I is I squared. Again, just for pure repetition, these middle terms sum to 0. That is why we use the conjugate. This I squared here is going to be replaced with -1 because the value of I squared is -1. So I will get then a 49 plus 4, which would give me a 53 on the bottom. So this is what's in the denominator, is 53. Now I'm going to come up here and I'm going to FOIL these. So 7 times 4 is a 28. 4 times -2 is a -8, and I still have the I. 7 times the -I is going to be a -7I. Okay, and negative times a negative is going to give me a positive 2I squared. These terms are like terms, and this can be replaced with -1. So I will have 28. That's going to be a minus 15I, and this is going to be a -2. So I can still combine these, which will give me a 26 minus 15I all over 53. Now it seems like, gosh, I might be able to simplify this more, like maybe 3 goes into all these. This is 5 times 3. This is not 3 times anything, although it feels like maybe it's divisible by 3, and maybe that one is 2, but it is not. That's 2 times 13. So that can't be simplified further, but again, realize that it may be written with the denominator separated out like this. So these are the same. You won't have to choose on the exam between these formats, but you do need to recognize that this is the same as this one.